When we talk about the companies shaping modern technology, we tend to assume they followed a predictable path. Steady breakthroughs, growing momentum, and a clear climb toward success. NVIDIA's early story couldn't be further from that. Its beginnings were messy, uncertain, and often defined more by what went wrong than what went right. Yet from that unstable foundation emerged a company that now sits at the core of the global AI revolution, supplying the computational muscle behind the technologies transforming the world around us. The story starts in 1993, long before most people had ever heard the word GPU. Three engineers, Jensen Huang, Chris Malachowski, and Curtis Priam, were working out of a small, modest office in California, united by the belief that graphics would eventually become central to computing. At the time, this wasn't a mainstream idea. Graphics were seen mostly as a gaming feature, something important but limited in scope. But the founders were convinced that real-time visualization, simulation, and 3D environments would one day become essential for far more than entertainment. Each founder brought a different perspective. Jensen, who would later become the face of the company, had grown up moving across countries and cultures, learning to navigate unfamiliar places and expectations. That ability to adapt became a core part of how he approached engineering. Nothing was fixed. Everything could be reimagined. He had spent time at AMD and LSI Logic, gaining a deep understanding of semiconductor design and the fast-growing world of computing. Chris, with years of experience at Sun Microsystems, had worked on workstation graphics and understood both the potential and limitations of the graphics hardware of the time. Curtis, meanwhile, had a gift for system architecture, having designed early IBM graphics processors and approaching hardware as if he were building an interlocking puzzle, where every piece needed to fit perfectly within the whole. Together, they had conviction, but not much else. Their resources were tiny compared to the established players dominating the industry. Companies like 3DFX and ATI had more engineers, more funding, and more name recognition. NVIDIA wasn't just behind, it was stepping onto a racetrack where everyone else had already completed several laps. And yet, the founders pushed forward, driven by the belief that the future of computing wasn't going to be defined by single-threaded processors, but by chips capable of handling thousands of operations at once. In the mid-1990s, that belief collided with reality. NVIDIA's first major chip, the NV1, attempted something unusual. It used quadratic surfaces for 3D rendering. It was technically ambitious, but fundamentally misaligned with where the industry was heading. Just as NVIDIA committed to this design, Microsoft introduced DirectX, pushing developers toward a polygon-based standard. Almost overnight, NVIDIA realized it had built its first flagship product on a foundation the rest of the industry no longer intended to use. Trying to fix that mistake pushed NVIDIA into its first real crisis. Their next chip, meant to correct the NV1 misstep, faced constant delays and performance issues. Manufacturing complications added more pressure, and the company burned through its limited cash at an alarming rate. Inside NVIDIA, engineers worked long hours chasing deadlines that always seemed to slip. What was meant to be the chip that got them back on track became a source of anxiety, uncertainty, and frustration. By 1997, NVIDIA was hovering dangerously close to collapse. Investors grew worried. Some partners stepped back, and internally, it became difficult to ignore how fragile everything felt. Many startups disappear quietly in moments like this, not through dramatic failure, but through the slow realization that the market has simply moved on. NVIDIA wasn't ready to disappear. Instead, the crisis forced them to step back and reassess everything. Not just the chip they were building, but the kind of company they wanted to become. They realized that incremental improvements wouldn't save them. If they were going to survive, they needed to leap forward, not just catch up. That thinking led to a radical decision: to build a new chip that would redefine what a graphics processor could be. The result was the GeForce 256. When it arrived in 1999, it immediately changed the landscape. Marketed as the world's first true GPU, it integrated key functions directly into hardware, allowing for far more realistic and fluid 3D graphics. Games looked better. Runs were smoother. Developers quickly noticed. hardware partners that had once hesitated began returning calls. And inside NVIDIA, the atmosphere shifted from fear to a cautious, growing confidence. People felt they were no longer reacting to the industry, they were influencing it. Yet even this breakthrough didn't foreshadow what was coming next. The GeForce line strengthened NVIDIA's position in gaming, but the company's most consequential decision came a few years later, when they took a step that few outside the company understood. In 2006, NVIDIA introduced CUDA, a platform that allowed GPUs to be used for general-purpose computing. This meant scientists, researchers, and engineers could use graphics chips to run simulations and calculations that had nothing to do with graphics. At first, CUDA seemed like a confusing bet. GPUs were fast, yes, but only within their narrow domain. CPUs handled everything else. But Jensen saw a broader trend forming. As data grew, algorithms would need far more parallel computation than CPUs could offer. A CPU is like a single brilliant worker doing one task at a time. A GPU is like thousands of workers, each handling a small piece of the problem simultaneously. It was a shift toward a new type of computing, even if few people understood it at first. Slowly, researchers began noticing CUDA. University labs started using GPUs to accelerate simulations. Scientists discovered that problems that once took days could be solved in hours. The platform wasn't mainstream yet, but it was building momentum. Momentum NVIDIA could feel, even if the rest of the world wasn't watching closely. Then, in 2012, everything changed at once. A neural network called AlexNet entered an image recognition competition and delivered results so impressive that they reset the expectations of the entire AI field. The crucial detail was that AlexNet had been trained on NVIDIA GPUs, not because they were made for artificial intelligence, but because they were the only accessible hardware powerful enough to handle the workload. This moment rewrote NVIDIA's fate. Overnight, researchers realized that deep learning, a field once limited by computational bottlenecks, thrived on GPUs. Labs began buying NVIDIA chips in bulk. Tech companies expanded data centers to include entire GPU clusters. Startups building AI products standardized their infrastructure around NVIDIA hardware. What began as a risky side project suddenly became the foundation of the most important technological breakthrough of the decade. From that point on, NVIDIA was no longer just a graphics company. It was becoming the engine of modern AI. As the company expanded, its revenue streams shifted. Gaming continued to matter, but the real growth came from data centers, massive facilities where AI models are trained, cloud services are hosted, and scientific simulations run at unprecedented scale. NVIDIA's chips became the fuel that allowed these systems to function. Film studios used their hardware for rendering. Autonomous vehicle companies relied on NVIDIA systems to train driving algorithms. Robotics, medicine, energy. Every field chasing high compute workloads began turning to the same provider. But success brought new tension. Competitors emerged quickly. AMD released powerful AI-focused chips. Google developed its tensor processing units. Amazon introduced its Trainium processors, and China began investing heavily in domestic alternatives. The US government imposed export restrictions on high-end NVIDIA GPUs, preventing them from being sold to China. Almost immediately, NVIDIA's role shifted from purely technological to deeply geopolitical, because most of its most advanced chips were, and still are, manufactured by TSMC in Taiwan, one of the most strategically sensitive locations in the world. Despite all of this, one advantage kept NVIDIA ahead: its software ecosystem. CUDA wasn't just a programming tool, it became the backbone of the AI industry. Switching away from NVIDIA meant abandoning years of development work, rebuilding workflows, and often sacrificing performance. For many companies, that simply wasn't an option. As artificial intelligence accelerated, demands grew. Models became larger, more complex, more resource-intensive. Robotics, digital twins, autonomous agents, drug discovery, all required staggering amounts of computational power. And NVIDIA's hardware sat at the center of that demand. We're entering an era where compute is becoming its own kind of global currency. a resource as essential to innovation as energy once was. NVIDIA didn't just build chips, it built the infrastructure that modern technology runs on. The company is no longer simply participating in the future. It is helping to define it. NVIDIA's rise wasn't inevitable. It came from decades of risk-taking, course-correcting, and reimagining what a chip company could be. From a cramped office with limited funds to a $3 trillion empire powering the AI revolution, its story is a reminder that the next era of technology doesn't always begin with a flawless plan. Sometimes it begins with a near failure, a risky idea, or a belief that the world will eventually catch up. And now that it has, one question remains. As AI continues to shape our future, how much of that future will depend on NVIDIA